Hello, today we are going to talk about triple integration. We have seen before how to use triple integrals for a simple geometry, like a rectangular box. But how can we apply that knowledge to a more complex scenario? First of all, we need to sort out the order of integration. And for that, we also need to assess if one variable is independent or not, and in that case, how many variables does it depend on? Let's say that for a certain three-dimensional region E, defined in x, y, and z, x is held constant, y depends on x, and z depends on both x and y. Well, in this case, the only way to write the triple integral as iterated integrals is the triple integral from a until b for x, g1 of x until g2 of x for y, and u1 of xy until u2 of xy for z over our function f dz, dy, dx. This means that we integrate first variables that depend on the ones behind them. So in this case, we would integrate first in respect to z, then to y, then to x. Okay, let's check out an example. Here, we are asked to evaluate the triple integral of the region f over the function x, where f is defined in x, y, and z, and x is bound between 0 and 1, y is bound between x and 2x, and z is bounded between x plus 2y and x plus y. Here we have the triple integral we were meant to evaluate, that can also be written as the triple integral from 0 until 1 for x, x until 2x for y, and x plus 2y until x plus y for z, over our function x, dz, dy, dx. As we already know, we should start integrating in respect to z, so we get the double integral from 0 until 1 for x and x until 2x for y, over our function x, times the integral of 1 evaluated to x plus y and x plus 2y, dy, dx. Now I'm just making some simplifications. So we get the same double integral over the function minus x, y. And now we are going to integrate in order to y. So we get the integral from 0 until 1 for x of minus x times the integral of y evaluated to 2x and x dx. Once again, I'm just making some simplifications. And here, finally, we are going to integrate in respect to x. So we should get the integral of the function that was inside the single integral evaluated to 1 and 0. Making some calculations, we get minus 3 over 8. As you already know, triple integrals are generically presented this way. However, it's also useful to know that for the same three-dimensional region A, you can be asked to evaluate the volume. So, in this case, we would get, as above, the triple integral over the region A, but instead of having f, we have a 1.